Hi, everyone. So we're going to learn about or review solving for equations today. What kind of equations? Just the ones with one variables in them. And the x could be in one place, like you see in number 1, or it could be in multiple place, like in both sides, like if you see in number 3. We could have fractions in them, we could have parentheses in them, all sorts of things, right? So if you could see right here, what we're going to do is this is a basic two-step equation. Why is it called a two-step equation? Because it's 2 steps, right? The first step is to get rid of the plus or minus. The next step is to get rid of the multiply divide. And if you notice, almost all the equations will simplify down to a 2-step equation. Sometimes they'll just automatically simplify down to a 1-step equation, but it'll all reduce down to this, okay? So if you'll take a look first thing we're going to get rid of, I noticed that my x is on the left-hand side, which usually it is. It doesn't always, but usually it's on the left-hand side. If it's not, it'll be on the right-hand side. So check one of the 2 sides, and wherever the variable is, that's where we're going to start getting rid of stuff. Okay, so the first thing we want to get rid of is that 15 because it's adding. So we want to get rid of the add and subtract first, and then the multiply divide. Think of reverse order of operations. We're undoing all that. So here we go. We're going to show our work here by subtracting both sides by 15. So notice right here, the 15s cancel out. Do you have to do that? Look, cancel out thingy? No, you don't have to. But, and then here, all we have left is the 5x is equal to 75 minus 15, which is 60. All right. And then now it's a 1-step equation because that was our first step, to subtract 15 on both sides. Now our second step is 5. We want to just get rid of the 5, not the x, because the x we want to leave there because we want to figure out what is x. Because if you go back to your middle school days, we ask ourselves 5 times something is equal to 60. What could that be? Right? So the way we undo that is we're going to divide by 5 on both sides, just using this fraction bar. And we're going to get x is equal to 60 divided by 5, which is 12. So if you remember, so if we were to plug that back in, 5 times 12, which is 60, plus 15 would be 75. Do you see how it works? That's the only number that will work. There's no other number that works there. Okay, so there we go. We're done. That's it. 2-step equation. First step, get rid of the plus or minus. Second step, get rid of the multiplier divide. That's it. So if you look at this right here, it's the same thing. It's a 2-step equation. We have something with the variable, and then we have an add and subtract, right? Add or subtract. In this case, it's add. And so here we go. Let's use yellow or orange. And then here again, we're going to get rid of the plus or minus. So here in this case, it's plus 14. So we're going to subtract 14 on both sides. And when I say both sides, there are some people who I notice who do this. They just draw a line. I like to draw a dotted line just because it's not actually a line, right? But this kind of helps us to see the left and the right hand side. What's on the left, what's on the right, right? And so this is what I mean by on both sides. See how we're subtracting 15 on both sides. So if that helps you out, use that. Now, what do we have left? So I just have t over 3 is equal to 29 minus 14, which is a 15, right? 15. And then how do we get rid of a divide by 3? Multiply by 3. So see, multiply by 3. And then we get t is equal to, because remember, when I say cancel out for when we multiply divide, is because it cancels out to be a 1. Because what's 1 times t? T, or 1t, which we just write as t. And then 15 times 3, which would be 45. There we go. So again, if we were to check that, 45 divided by 3 is 15. 15 plus 14 is 29. See how it works? And now here, so these two were 2-step equations. So this one right here is where we have variable on both sides. So how do we get this to look like a 2-step equation, right? So if we could just get rid of this minus 10t, or we could get rid of the 4t on the left. Either one, it does not matter, right? It will give you the same result. It'll just, the x will either be on the left or the right. Doesn't matter. Okay, in this case, I would like to add 10x, not 10t, 10x, only because, that keeps everything positive. I could subtract 4x on both sides. So if you feel like you're up for a challenge, do that while I'm doing this. And again, always feel free, please pause it right now, right? Or maybe you already did. And then try it yourself. Because the best way for you to learn is for you to do it. Okay. You can't, anyways, I won't say it. I'll just keep on going here. So this is going to be 7 because we did not use that yet. Plus 14x is equal to 63. All right, so now I notice that in front here, I have the 7. Normally it's in the back, but that's fine. It's still, we're still going to get rid of it the same way. And again, we're not looking behind the 7. We know that we're adding, subtracting, but look in front, right? That's going to be a positive 7, right? Which means I need a negative 7 or a minus 7 to get rid of it, because we want, when we're adding and subtracting, the way we say get rid of it means make it equal 0, right? 7 minus 7 is what? 0. And what's 0 plus 14x? 14x. That's why we want it to be 0. So if it was equal to 1, what's 1 plus 14x? Just 1 plus 14x. That's it. There's nothing we can do about that. Not good. All right, so here we got 14x, and then 63 minus 7, which is going to be 56. All right, and here again, 14, we're going to divide that by 14 on both sides, and you get x is equal to, want to say 3, 4, 4? Yeah, 4. Okay, and so if you were to check this again, I'm just saying, so 4 times 4 is 16. 16 plus 7 is 23, right? So, okay, that should be 23. So let's plug that in there. 10 times 4 is 40. So 63 minus 40 is what? 23. What? See? That's how it goes. So that's how you deal with that. So you get everything to look like a two-step equation. That's the whole point. And then we just solve it. Because solving a two-step equation is not terribly hard, because it only takes 2 steps, right? There we go. And so let's try these ones out. These monsters out. All right, so I'm going to take 4, put it right here. Ooh, I'm missing something. Let's try that one more time. Ooh, take the 4, put it up here. Take the 5, put it right about there. And take the 6, put it over there. Again, please feel free. Try these out on your own. It's a great idea. Okay. So again, variables on 2 sides. So we want to bring it to one side. So for me, I noticed that this is a minus 9x. So I'm like, oh, I'm just going to add 9x. Make that easy. It does happen to be on our left. Our x's end up going on our left, but that's fine. Again, so this is going to be 10. This is x plus 9x, which is 10x. My 9x's cancel out. So all I have left is a 2. That was the whole point of that. Now it's a 2-step equation. Again, we're going to get rid of the 10 that's we're adding and subtracting. So subtract 10 on both sides. Why? Because 10 minus 10 is 0. Now we on the left-hand side is just 10x, and what's 2 minus 10? Minus 8, or negative 8, we should say, right? Either way is okay. And then we got this 10 right here, and it's multiplying, so we're going to do the opposite of that, or the inverse is what we call it. And so that's going to be just negative 8 over 10. I'm going to simplify this. I just try not to use these in, just leave them as fractions. It's good practice, and it's more accurate. In this case, it, 0.8, negative 0.8, right? That's exact, right? But with the fraction, you know that for sure it's exact. With a decimal point, you don't know if it's rounded. Was it exact? Unless it was stated that was rounded, right? So this one, 2 goes into both of these, so it's going to be negative 4 over 5. There's our answer, right? And we're going to go to number 5 right here. Oh, I noticed that I have a minus 4x on the left and a 2x on the right, so I have x's on both sides. So again, I'm going to just add 2. Nope, just kidding. You didn't see that. Add 4x, because and this will bring my x's to the right. And we haven't done one of those before, but that's fine, because it's still the same thing, right? And for some people, this bothers them that the x is on the right, but that's okay. You will be fine. So what do we have left on the left? Is the 24 is equal to 2x plus 4x. And now, do you remember what I said when most of them simplify down to a 2 two-step problem, but notice here, it's just a one-step problem, but that's even better than a two-step because it's faster, because we're almost there. It's just one more step. All right, and we're going to now, since we have that 6, we're going to divide that by 6, because literally we're asking ourselves, well, what times 6 will give me a 24? I'm sure many of you guys already know that. It's just gonna be 4 is equal to x. And so I just ask that you rewrite that as x equals to 4. Just x equals 4. You have the variable on the left at the very end. Okay. And then if you look at right here on the, what is it called? For 6, I have variables on both sides and no other numbers. And that's fine, because we're going to do the exact same thing. Get the variable on one side. So I'm going to subtract 2x on both sides. Well, what do I have left on the left? What do I have left on the left? Just what's 2x minus 2x? 0. So we actually have to write down 0 this time because there's nothing else left. Like here, like this was 0 too, but we didn't have to write down because what's 24 plus 0? 24, yeah, 24 plus 0 is just 24. So that's why we just didn't have to write down the plus 0 part. But in this case, we do because there's literally no other numbers there. So here's 0, and 3x minus 2x is going to just be x. So here we just have our answers. X is equal to 0. Is that true? If you put it in, 2 times 0 is 0. 3 times 0 is 0. So therefore, 0 is equal to 0. Yay, it works. All right, and we're going to move on. We have a couple more questions to go. I'm going to just move these guys a bit. You're going to be right here. And number, oh, I don't know if I have room for that. So we'll put these down here. We'll just place them all now so that we don't have to do them later. Our last problem right here. That'll be our problem 11. All right, we'll end on an odd number. Okie dokie. So if you take a look at this, let's use pink. Now, we have parentheses, and normally I'd be like distribute, but if you notice, they're the exact same, like they're like terms. So what's 3 plus 3? Well, that's 6. So okay, so we got 6x is equal to 6x. Oops. No x. It's not x. 6z is equal to 6z. And you're like, wait a minute, 6z is equal to 6z. Okay. We're just going to keep on going. And what do we do to both sides? Let me actually make that black. There we go. And then, so what we're going to do, we're going to just subtract 6z on both sides. And what do you notice? We get 0 is equal to 0. Is it true that 0 is equal to 0? Yeah. But we also don't know what z is because we didn't solve for it because our z is just canceled out. So therefore, remember what we said. This z can be anything it wants to be, because think about it. Whatever this z is, the other z is, right? And if we're going to multiply both of them by 6, it's still always going to be the same answer. So we call this infinitely many solutions. Meaning x can be whatever it wants to be. There we go. This is our official answer. There are infinitely many solutions. All right. So the number, so number 8 right here, we're going to, now I notice that, ooh, we have parentheses, but 5 does go into 20 evenly. So let's just simplify that part. So 20 divided by 5 is 4. We've got 4y minus 7 is equal to 4y plus 3. Now, again, we're going to get the variables on one side to make it look like a two-step equation, right? So I'm going to just subtract 4y and subtract 4y. And you may have noticed, wait a minute, Ms. Lee, they just cancels it out on both sides. So all we have left is negative 7 is equal to 3. What? And if you notice, this exact, is that true since negative 7 is equal to 3? No. So in this case, there is actually no y that will work here. Nothing will work in here. Okay, you can try any number you want, it won't work at all, ever. Like none, right? And so this is no solution. And the reason why that makes sense, the no solution, is because remember, if you're taking the 4y and then you subtract 7 from it, would you ever get the same answer if you take the same 4y and then you add 3 to it? That makes no sense, right? They're never going to be equal because remember the y's are the same number. We don't know what that number is, but it's the same number. And if it's the same number, we multiply it by 4. One of them you add 3, the other one you subtract 7. You can't end up with the same number. So that's why it's no solution. Okay, when you end up with something like this, no solution. All right, number 9. We're almost there. And now we have parentheses that they're not like terms. So now when they're not like terms and we can't add them together or subtract them together, we're going to have to distribute them. So we're going to take the 6 and you distribute it with this x here, anything inside the parentheses. Okay, so you're going to end up getting, so this is the x out here. So x plus, so 6 times x, which is 6x, x times -1 is -6. Remember I said negative and the minus, I'm going to kind of interchange, right? So that's going to be -6 is equal to, now I have parentheses here with a 7 on the outside. And it's going to huff and puff and blow these down. So this can be 7 times 3, which is 21, plus 7 times x, which is going to be 7x. See how that goes? See how the 7 was distributed with everything inside the parentheses. And notice the 6 did not get distributed to this x before because it's outside of the parentheses. It don't care. Okay, it's just focused on whatever's in those parentheses. So now I'm going to combine like terms because I can combine them because they're all on the same side. Let's make them look a little simpler. So we're like, okay, well, we got x plus 6x, which is 7x minus 6. And then I'm just going to copy this down because I didn't do anything to them yet. And there's no like terms to combine. And then from here, we're going to get the x's together, right? Because we want to make it look like a 2-step equation. We're going to subtract 7 on both sides, or 7x on both sides. Don't just say 7, 7x makes a difference. Like, wait, what? 7x minus 7x? If you have 7 x's and you take away 7 x's, how many x's you got left? This many, 0. So all you have left is -6 is equal to 21. Yeah, that's not true. So what do we know? It's no solution. What? No solution, just like that. Now, if the answer was like 21 is equal to 21, then we know, oh, infinitely many solutions. But in this case, all my x's cancel out and I got just numbers. This is what happened. All right, and let's try number 10 now. 10 looks daunting, but it's not bad. You just take it step by step. All right, and I notice here, oops, did I push the wrong button? All right, I got some parentheses that I cannot add the insides to. So I'm going to have to distribute them. So that's going to be -14. Don't forget my negative, plus 2 times 5, which is 10, right? I'm going to just include the rest of those because oh, and I noticed on the right hand side, you see the right hand side? Do you see what I see? You can combine them. So 3x minus, what is that thing called? Minus 15x is -12x. Plus 3, excuse me. All right, so now, ooh, I still have to combine like terms here because I wasn't able to do that before. So I'm going to do that now. So the minus 14x plus 2x is going to be minus 12x plus 10 is equal to, well, I'm just going to copy that down because I'm just copying it down because I didn't use them yet. Let me make that black so you can kind of see where I'm going at. So now it looks exactly like problem 3 where we had 2 variables or a variable on both sides and some numbers, right? So again, we're going to get the x's together. Wow, we have a lot of no solutions here, but this is what you would do. This is what happens sometimes, right? You come up with life and life just gives you no solution. What do? You just keep on solving to say there's no solution, you move on. Does not equal. So you're just like no solution. All the ones I picked do not have solutions apparently. Thinking. Right. So there we go. But again, the concepts are always still going to be the same. It's not going to change. So here we go. We have 1x here. And I notice there's a lot of things going on. There's not an x on this other side. So, okay, so I'm going to start with what I got. I'm going to first get rid of this, okay, get rid of this divide. And again, some of you guys may be like, well, how do you know, Miss Lee? How do you know which one to do first? I will say you won't every situation is a little bit different, like, right? Because you guys have problems too in your life. And do you approach every single problem the same way? You shouldn't. Like, do you talk with every single person the exact same way, right? It depends on, what's going on, what the situation is, right? And so that's the same thing with equations. You kind of have to see what's going on first, right? But the basic concept is going to still be the same. Just like when you talk to people, basically the concept is be nice, or you should be nice, be polite, be respectful, right? That's the same way. At least that's how I try to live. But doesn't always come across that way, but I do try. But right, but the same thing with equations. And the only way you're going to know, like, better how to deal with these problems, is if you deal with more problems. And when I'm saying problems, I mean like math problems, not like life problems, right? That's why I like these math problems, because they always have answers. Life doesn't always do that for you. Bad days. All right, so we got 5 divided by 5. Life lessons learned in the math class. Now, I did not get rid of this parentheses here, so that's why it's still here. Minus 8 is equal to, now what is 16 times 5? 80. You see? So now there are 2 ways to get rid of this 4. One of the ways is to distribute, right? So we can get rid of the parentheses. The other way, I should have said to get rid of the parentheses. Sorry. The other way to get rid of the parentheses is to divide by 4. And the reason why I would want to do that is because I noticed this 80 can be divided by 4. So we're going to do 2 different ways. So we'll go on a little field trip here. So this is what we do in Earth 1. Here's what we'll do in Earth 2. Okay, you could pick whichever one you want, depending on what Earth you're from. I'm just kidding. And if you don't know that reference, then that's fine. So if you notice right here, I'm going to just divide it. Okay, we're going to just divide it. And I notice the 4s are going to cancel out. And what do we have left? On the left-hand side is x minus 8 is equal to 80 divided by 4, which is 20. Do you see how much simpler it looks like now? And now we're going to do, well, I can just get rid of the 8. So that's a minus 8. So we're just adding 8 to both sides. And that's going to be x is equal to 28. Boom. Okay, so now we better get the same answer here. Getting a little nervous. So in the Earth 2, we're going to say, well, now we're going to distribute. Now, I'll say most people just distribute because they get into a habit of just distributing. But for me, I like to find shortcuts, right? So we're going to distribute. So 4 times x, which is 4x, and then 4 times negative 8, which is going to be negative 32, or minus 4 times 8, which would be 32, is equal to 80. All right. Now, this is exactly our 2-step equation. And we're going to now add 32 to both sides. And we get 4x, because we did not use it yet, is equal to 1, 1, 2. All right. And then we're just going to divide this, right? Because divide that by 4, divide that by 4. And x is equal to, okay, 4 goes into 11 2 times because it's 8. And with a remainder of 3. So 4 goes into 32 8 times. Yay. That's my short division that I learned a long time ago. And do you see how they're both equal to 28? One way's a little bit faster, right? And a little bit smaller numbers. And the reason why is because we got rid of that 4 first. So here everything is multiplied by 4. Here we're dividing by 4. So these numbers should be getting smaller, right? Because we're dividing instead of multiplying. But either way, you're still going to get the same answer. So I would only choose this way if this number on the right is divisible by the thing that you're trying to divide by. If this was like 81, I would not choose that way at all, period. I would go this other way. I'm just saying. So again, the more you practice, the better it will become. All right. Hopefully, I hope this helped you out. Go back and try these again if you did not do them. And even if you did do them and you still need some help, I would do that and then press play to see the explanation again. All right. Talk to you later. Bye.